Hi folks, so in this video, let's actually do an example of evaluating an arithmetic series. So we talked how in the last video, if I have some, or maybe not the last video, but a video previously, if I want to add up terms a1 to a2, a3, etc., the first n terms, so again, all this is right here, is the first n terms. And again, maybe you don't have the first term, maybe you're starting off with the third term or the fourth term. But again, when I say A1 here, it's really just the first one that you are interested in, and you can always label the first one that you actually care as A1. So you should just, in general, always do that. You can call it A0, and then these formulas will look slightly different, but as long as you understand the general idea of these formulas, you'll be fine, okay? And I will explain that right here. So again, the first n terms, if I want to add those up, again, well, that's the nth partial sum. So that's Sn here. That's the nth partial sum. I'll just abbreviate PS. And that's going to be equal to the number of pairs. So we talked about how this thing is really just the number of pairs. Okay, and the n right here, that's really the number of terms. And the number of terms, the number of terms divided by 2 gives you the number of pairs, and we saw how every pair, if I add them up from the outside and working inward, every pair has the same value, and that's where this comes in. So this is the value of the pairs, or the sum of the pairs, I guess you could say. The value of each pair. And again, A1 is simply the first, and AN is wherever you end up, so it's the last. Alrighty, so let's actually see this in action. So we want to evaluate S40 for 2 plus 5 plus 8 and so on and so forth. So again, we'll call, let me just copy this, it's a little crowded here. We're going to call it 2 A1 because there's no reason not to. Okay, again, that would mean A3, or A2, sorry, is 5, A3 is 8, and so on. Now eventually, we need to get to A40. Okay, so we can use the fact that, well, first off, confirm that this is actually an arithmetic series. Well, because the sequence or the terms follow an arithmetic growth or linear growth. We can see from 2 to 5 to 8, it goes plus 3, plus 3. So this is indeed arithmetic. So always double check that first. Okay, well, if we know it's arithmetic, then we can actually create an equation pretty easily for this 40th, for the general term, and therefore figure out what the 40th term would be. Okay, so we know that our common difference, or our growth rate, is, I'll call it D, is 3, in this case plus 3 plus 3. And we know that our first term is equal to 1, is equal to 2. Again, you could do it any way you want. So the way, probably I see most people do it, is to create an equation for the general nth term using the first term. So in sequences, this becomes really common. It's A1 plus D, the common difference, times n minus 1. Whoopsies, we're running low on battery. Okay, alternatively, you could start with A0, the imaginary A0, plus Dn. This is easier for me personally, although it doesn't make this nice, sexy formula that you'll see later. But for us, so this ends up being 2 plus 3 to the n minus 1, or let's see, the 0th term would be negative 1 in this case, plus 3n. So these are exactly the same. That should be a minus, not equal sign. Okay, so these two equations are exactly the same, and you can see here, if I distribute this, you'll get 2 minus 3 plus 3n, which is the same thing. Okay. But here's why this is actually really nice to use this one. Again, you don't necessarily have to do this. Okay? Well, actually, we'll get there later. So either way, now we can figure out what A40 is. And that's going to be equal to, well, I'll just plug in n equals 40 into one of these equations. Either way, you should get the same thing. So I'll plug it into this first one here. 3 times, let's see, 40 minus 1 would be 39. And I'm just going to plug that in over here, again, to this one, just to show that doesn't matter. 3 times 40 here. Okay, so this is going to be, I'm going to need a calculator here. Well, actually, I'll do it this way. This is going to be 120 minus 1, so that's 119. 30, well, let's see. 39 times 3 That's a little hard to do. So we'll do 40 times 3, and then we'll subtract the 3. So that's 120, but take away 3 because there's not 40 threes, there's 39 of them. So that's 117. 117 plus 2 is indeed 119. So you're actually the same thing. Again, all this was, the whole purpose of this was to use the formula for an by building in the sequence, building the equation for the sequence, to figure out what the 40th term is. Because now we know what the last term is, we have that. We know what the first term is. Do we know how many terms there are? Absolutely, we do. We're going from term 1 to 40, so there are 40 terms. 1, 2, 3, 4, 5, all the way to 40. So our S40 is going to be equal to 40 over 2, and again, 40 over 2 because there are going to be 20 pairs, and every single pair is going to have this value, 2 plus 119. Oops. So if we evaluate this, this will be 20 times 121, which ends up being, what is that? 2420. Okay. I do want to kind of use this time here, because I'm always kind of fast, to just show you this alternate formula. So I'm going to connect this formula, excuse me, and I'm hoping that we can do this before we run out of battery, is that if I just say Sn, again, I'm just going to copy this, of A1 plus An, but again, we know that you can create A sub n, by using A1 plus D times n minus 1. Again, all this says is that to figure out the nth term, you need an equation for it, and you can use the first term to get the equation for it. Okay, and if I just do a little substituting here, we'll see this. A1 plus A1 again plus D times n minus 1. And if we collect our like terms here, this is just going to come out as n over 2 times 2 times A1 plus D n minus 1. And this is an alternate formula that you might see in some places. Unfortunately, my way of preferring to use the 0th term doesn't help us quite here, but again, it doesn't really matter. This is just simply an alternate formula, and sometimes this formula could be a little bit more helpful just to speed things on along. But again, it's not necessary, just as long as we know the basis of where this formula comes from. Okay? So again, I think the best way to go about it is remember less and just understand how to add the principles of how to add these arithmetic series, excuse me. So hopefully that helps, and we'll do a couple more examples as well, because maybe these are fun to do. Thanks for watching, and I'll see you later.